Hey everyone, welcome back to the channel. In the last video we learned how to find the characteristic polynomial of a 3 by 3 matrix. Today we are going to use that skill to find the eigenvalues of a 2 by 2 matrix. Here we have a question, find the eigenvalues of the matrix A equal to 2 1 1 2. Remember, eigenvalues are special values as they satisfy the equation AV is equal to lambda V, where A is the matrix, V is the eigenvector, and lambda is the eigenvalue. To find the eigenvalues, we need to solve the characteristic equation which is given by determinant of A minus lambda I equal to 0, where I is the identity matrix of order same as that of A. Let's get started. Consider the matrix A. For A minus lambda I is 2 minus lambda 1 1 2 minus lambda. So therefore, the characteristic equation will be the determinant of this matrix, that is 2 minus lambda 1 1 2 minus lambda is equal to 0. On solving the determinant, we get 2 minus lambda multiplied by 2 minus lambda, that is square of 2 minus lambda, minus square of 1, which is 1, is equal to 0. Simplifying the first expression, we get 4 minus 4 lambda plus lambda square minus 1 is equal to 0. That gives us lambda square minus 4 lambda and 4 minus 1, that is 3, equal to 0. This is a quadratic equation in lambda, and we can easily factor this out as lambda minus 3 and lambda minus 1 equal to 0. Solving further gives us the root as lambda is equal to 1 and lambda is equal to 3. And that's it. We have found the eigenvalues of the given 2 by 2 matrix A. In the next video, we will explore how to find the eigenvectors that correspond to these eigenvalues, so stay tuned. Let me know if you would like me to make any changes or addition to these. If you found this video helpful, please give it a thumbs up and subscribe to my channel for more math tutorials. And don't forget to share it with anyone who might be struggling with linear algebra. Thank you and happy learning.